Kind of continues on from yesterday's lecture on objects, except now we're kind of moving less from just objects as like a data store, like a dictionary where we read information, but more onto the more practical side of objects, which is how we use them, right? And one of the things that really like we've been doing continuously so far in every workshop is write functions. But we haven't really talked too much about functions yet, like what they are and kind of, and a bit more nuance around them. In today's lecture, what we're going to be doing is talking about functions and kind of helping you understand how portable they are. Like, remember how earlier we talked about being able to reuse code from different places? And really, that's why we write functions, is because we want to have something that we can reuse over and over again. We're going to combine that into an object and kind of hopefully make it a little bit clear about why objects are so popular and why it is that objects are often used not just to store information but also to process information as well. Okay, so methods you can think of for now at least they're synonymous with functions, but really it's just a series of actions that you can perform right on a given value. We've seen a lot of built-in functions already with arrays and objects. Things like if I have an array, if I want to figure out, if a given element exists, I do array.index of, right? Like I know in the workshop we basically wrote our own version of index of, but organically speaking, index of function comes with all arrays, and so the function becomes something that we use. But we never really think about kind of what to do because someone else already built the logic for it. With methods, one of the things that we really want to talk about here is just, well, that was really nice and nifty, right? To be able to have something that kind of built in and we can reuse over and over again. And so far, we've written functions that kind of does something very similar. Which is I write a function, and then if you ever look at your test and the way we run it, right? If I have 4 test specs, what I'm really doing is I'm just running that function 4 times. Each time I could feed a different input and expect a different output, but organically that's how the tests work. So if we want to create our own method, our own function, but now instead of just saying, hey, here's a function by itself in a vacuum, and we want to tie it in, we want to package it together with an object in a way that we can deliver this whole thing. Now we're getting into the realm of object methods. Okay, so yesterday we talked about objects, we talked about key value pairs, and we mentioned that that the key for an object always has to be a string, but the value for an object can be any data type whatsoever. It can even be other objects. So if it can be any data type, then it means that one of the things it's able to be is a function. So if I wanted to write our own function, here, if you look on line 5 there starting, we have this key called myMethod, which is still a string, and the value of it is a function. Looking on the right-hand side, it looks like an anonymous function in some ways, right? Anonymous meaning we don't give it a name. It's a function that takes in no inputs, and all it does when we run it is we console log out I'm from a method. And just so you know, the distinction between a method and a function is that functions that belong to something are called that thing's methods. So like index of function, the way that you wrote it in your workshop, it's a standalone thing, right? That you just call like if I made my own index of, I called it David's index of, that's a function because I can just call out of the blue David index of, right? And pass it in an array, I will do that. However, if that function was a part of a class, or in this case, part of an object, then that function becomes that object's method, right? So it's more of a semantics thing. But if you ever see those two things, know that, I guess no pun intended, functionally they're the same thing, right? It's just a matter of how you want to call one versus the other. So when we talk about index of, usually we don't say the index of function, we say the index of method, because the understanding is that index of belongs to the array. Like you can't use index of the way that the array class has it without using it on an array. I can't just call it kind of out of the blue. So that's just kind of like the explanation there, right? But here, if you look at the way that we do this, on day 2 or maybe even day 1, we talked about how every function or method in JavaScript, the only way to run a function is with the open and close parentheses, right? That's the universal sign in JavaScript for invoking something. And so if we don't see the open and closed parentheses following a function or a method, it really means nothing's being run, right? And so when we look at line 5 there, we define this key called myMethod. And on line 11, what we actually do is we take the object that we create on line 1 there, the Grace Hopper object, and we call gracehopper.myMethod. In this case, we're using dot notation to access the value, right? We could very easily use bracket notation too. There's nothing wrong with it. In this case, we just happen to make that choice. However, the point here is that if I don't have that open and closed parentheses here after line 11, what that does is that just says, hey, get me the value of the myMethod key on the Grace Hopper object. And in that case, what would I get back to me?
What is this function?
Yeah, it would just say, hey, here is a function, right? It makes no judgment around like what to do with that function. It just says, here's a function, right? This could be a string, this could be a number, this could be anything. And without these open and closed parentheses, if I just do Grace Hopper.myMethod, that just says what is about, right? But by adding this open and closed parentheses, right, it's almost like we're chaining something together. And then in this case, what that is basically when I see this open and closed parentheses, or rather what JavaScript sees that, what it understands is, okay, I'm going to evaluate, how we talk about going from left to right, the way we chain together nested arrays, or how we chain together access to nested objects. Here, we go from left to right. We do gracehopper.myMethod, and the understanding is whatever this part gives back to us, we then do the next thing with it. And the next thing is an invocation. So that kind of just says, okay, whatever value is in gracehopper.myMethod, I expect it to be invocable, or I expect it to be able to call it. And so when we run this as written on line 11, what we're really saying now is, hey, whatever this method is, actually run it, right? And that's when we run it, we actually print out I'm from a method. If this open and closed parentheses were not here, this would just basically let you know that, hey, this is a function, right? It wouldn't run it. I'm repeating this over and over again just because in today's workshop problems, a lot of times, like, you just need to be very, very clear about when you're passing a function, as in when you're passing a function when you're moving a function from one place to another versus when you're actually trying to use the function, right? And the open and closed parentheses should be like your guide in all of these cases, right? If you want to actually run a function, use the open and closed parentheses. If you want to just take something as a tool and just say, hey, why don't you use it somewhere else, then you don't want to use the open and closed parentheses. Okay, so this is probably a bit more of just like a FYI thing. Kind of like knowing, kind of like how we name variables. Typically speaking, functions are also something you want to name very verbosely. I think for the most part, we've done a pretty good job of that. But usually when I read, like in this case, because these are functions on the object, usually the name of the function should be something that kind of gives you a pretty good sense of what this thing does, right? Like array, when we use the dot reverse method for arrays, right? Like, or index of, like, these are things that you want to name it so that it kind of gives you a good sense without having to look into the actual function itself. Okay. This isn't too much different, but the one thing we want to note here is just that, because the value is a full-on function, well, it enjoys all of the capabilities that a full function does, right? One of the things that makes a function so powerful is I can give it whatever input I want and it will process it. So in this case, this function can also take in an input, in which case we're taking a year and we just subtract that minus whatever year we want to start as a baseline, right? So here on line 14, when console log gracehopper.getAge, I can also pass it a value as well. So this is just to illustrate the example that these are, even though they're quote unquote the value in an object, these are full functions, right? They take in parameters, they can return values, they can do everything that a full function does. Okay, this is super critical for now. The next slide kind of refers back on this, but just notice how here we have an object, we have a first, last, rank, which I guess first name, last name, and the rank, and then we have a greet function that basically takes a name and logs out, hi, I am Rear Admiral Hopper. And so if we were to call this function and we pass it something called like Karen, then it would greet someone named Karen. right? But one of the things that one of the like a, not even like a concept, right? But like something you'll hear a lot in programming is something called writing dry code, DRY. And the dry is an acronym. It stands for don't repeat yourself. And that's like a major tenet in programming, which is this idea that like anything we write, in an ideal world, we only write once, right? If writing the same thing over and over and over again, it means we're being inefficient with our code. It means there's probably some way for us to extract that and basically write everything that's critical only one time. So here, notice how before I had to manually type in, hi, I am Rear Admiral Grace Hopper, right? And and it's fine, except if I was to create another object, well, then I would need to retype all of that too, right? The point here is that Grace, I am Grace Hopper, Rear Admiral. Those are all values that already exist in our object, right? And really, if we want to make this as flexible as possible, the idea here is that hey, rather than retyping Grace Admiral Hopper, because once again, right, what if I change this first name property, right? If I change this first name property, so if I go back to the previous slide here, where it was this, I guess I am Rear Admiral Hopper, right? So the last name is Hopper. If I was to ever change the last name on this object, say, hey, rather than having it be Hopper, let it be David now, right? It also means someone, including myself, will need to remember that, oh, by the way, I also wrote Hopper manually. We call it hard coding. But we also manually wrote Hopper there, right? So I also need to go in there and change it as well. And now we're starting to get in the realm of having this kind of black box / mystery knowledge / like someone needs to know this code really, really intricately to know how to change it. When in reality, the code should be simple, right? It should be self-explanatory. It should be a place in which like we can do something once and we can kind of understand how the changes will propagate downwards. So the benefit of doing it this way now is rather than actually going and saying Grace Hopper Rear Admiral, we can actually just put in the Grace Hopper object that we're referencing here, right? We can put in that object and we just access .rank and .last. And now what that helps me do is if I ever go to Grace Hopper and change the last name to David, then whenever we call this function, that will also automatically change, right? Because it will go to Grace Hopper and ask, okay, what's the last property or what's the rank? And it'll say, this is what I have right now, and we'll just use it right away. And so once again, all these changes that we're doing, what we're doing is we're making the code, we're making the functions a lot easier to use, easier in the sense that there's less manual upkeep. Writing code in the real world environment, writing code is most often the easiest part, right? If you were to pitch a project to someone, including your engineering manager, more often than not, like their big concern is not like who's going to write it today, but it's who's going to maintain this for the next 6 months, 12 months, a year, 2 years, 5 years, right? Because it's hard to launch a product and not support it going forwards. And so a lot of times when you write code, you also want to think about how do I make this code as extensible or as usable as possible. So these are just examples of things that we do, best practice that we do, where we say, okay, if I know that last name and rank is our properties that could change at any given time, then in my code I should be trying to basically reflect those or refer to those things dynamically as much as possible. Okay. And then just to take this one step further now, before I was trying to call Grace Hopper.rank, Grace Hopper.last, right? But even in some ways, even that's like a little bit less efficient, right? Because I'm kind of tied to this idea, like, well, one, I've typed Grace Hopper multiple times, right? But the other thing that it also does is it basically means if I ever create another like object in this way, if I call this rather than Grace Hopper, I call it Full Stack Academy, like let Full Stack Academy equals this, and I want to copy a lot of this code over, I wouldn't be able to, right? Because before this was Grace Hopper, right? It was kind of, once again, manually hard-coded. It was physically tied to this Grace Hopper object. So how do we extract out that logic here? And so now we have this idea where we'll start talking about the concept of this. This is usually very hard to explain verbally because obviously it gets confused with all other words. But what this is, is it's a reference to the object that, in this case, like when we talk about this in the context of object methods, this refers to the object that the method is tied to, right? So if I use array.indexOf, this would refer to the array, right? And the important thing here is to know that when it's referred to that array, it means it's tied to like that instance of that array, as opposed to, say, the array class. All right. So when I use this now, what JavaScript is going to say is, oh, you have a function. Okay, cool. You want to refer to this. Well, this is almost like your owner, right? Like this is like what you belong to. And what does this function belong to? It belongs to this object. So JavaScript will say, okay, this is now your object, or rather this object is now your this. And so when you do this.rank, JavaScript is smart enough to say, okay, your function, who do you belong to? You belong to this object. And then when you look up this.rank, this object becomes this, and then you're looking for the rank property on this object. That's kind of a bit of a tongue twister, probably harder for you to understand than for me to say. But hopefully the idea is coming through here, where by using this.rank, I can actually just copy and paste this code now, right? I can take this function, I can copy and paste it and just like use it wherever I want. And now I'm kind of not foolproof, but now this code is super flexible because I can put it in any object and we'll be able to understand that. Oh, like when you say this, you're talking about like in this object, what is the current rank? What is the current last name? Sorry, what was your question?
Yeah, so with this, is it in terms of scope, is it always within its most inner block? That is what it's referencing?
Yeah, so let's talk through the next two slides and we'll come back to answer that question. It'll probably be best to look at the two slides and we can do some like live trials to kind of answer any relevant questions. It's hard to verbally talk about, really. And there was another question over here, I thought.
I think it'll be answered the same.
Okay, cool. Right, so we're going to talk about this for a while. Okay, so when we talk about this, let's just kind of be very like direct here, right? Like let's just actually look at what this is. We have a function called getThis, right? And the function just returns this, right? This is, once again, something that's built into JavaScript. So this exists without you having to define it. I actually don't know if it's a reserved word. I imagine it must be. But just know that this is something you have to like, you don't have to say like, let this equal whatever. Like this comes built into JavaScript. This is a constant that's innate. So on line 12 there, when we say let return object equals GraceHopper.getThis, right? I'm actually executing this function. What is this function? This function returns this. Okay? Nothing gets console logged. It gives back this. And remember, look, we're capturing the value of this in this variable called return object, right? If this let return object equals was not here, then this function might as well not have run, right? Because we're returning something that we never stored. And so it's like me throwing a ball at you and you don't bother catching it, right? Like the ball just kind of flies off. So basically, after we run line 12, we can say that this and return objects are now pointing to the same thing. I say pointing to the same thing, and it's something we'll talk more about tomorrow. But for now, hopefully, like visually, that makes sense to you, right? Like I have two variables, and now they're all pointing to the same thing, which is this. Okay. On line 13 and 14, then if we console.log out return object.first, and then we console log out this part down here, whether or not return objects is triple equal to GraceHopper. Two things. Or actually, let's go through these lines first, and I'll talk a little bit more about this last line here. Return object is just effectively like this object, right? So when I talk about this object dot first, it's just GraceHopper, or sorry, it's Grace, right? So like so I guess the point of this is to prove to you that this really does become like a stand-in for this object, right? Like they are one and the same thing. And in fact, we really kind of drive that point home with this last statement here, right? Where we compare return object or this to GraceHopper, and what we get is true, right? These two things are triple equals true. What I'll say here is in yesterday's workshop problem, I know historically, right, whenever we've compared objects or compared arrays or compared any non-primitives, we always get false, right? Like I can make two arrays identical that both have the values 1, 2, right? When I do a triple equals in JavaScript, it comes back false. And I told you like that's because you really can't compare non-primitives with triple equals, right? This is a little bit of a different idea. And for now, like don't think about why this is. We'll talk about like this tomorrow when we talk about like references versus values and how JavaScript interprets those two. Just accept this statement for the point to show you that this and Grace Hopper are the same thing. Okay, like sorry to like punt this off, but it's like a much deeper discussion, and I don't want to kind of sidebar that with understanding that this is just trying to tell you that this is identical. It's synonymous to this Grace Hopper object. Yeah, Dimitri?
If I understand you correctly, if I were like I'm trying to let return object,
yep.
If I were to change Grace Hopper object, the return object would change as well.
That's a good question. So, sorry. Let me make sure that we can just test out. So your question is.
It's not like a copy; it's more like a reference.
Yeah, it is. So let's just test it out. Okay, so before I like confuse anyone any further. Okay. So this is our code. We run it. We get exactly what we're saying. And what you're saying is here. Let's say we say Grace Hopper.
Change first.
Oh, sorry. Grace Hopper dot first equals Dimitri. Okay. And really like, and really that's why like I guess trying to preview for tomorrow. That's why when you compare two arrays with the same numbers, they're not triple equals true. Because if I change one array, it doesn't change the other array, right? In this case, when I change one side of the equal sign, it changes the other side of the equal sign. And that's why these are considered triple equals in JavaScript. So like, it's not just like, this is like, oh, a copy of the value that we Xeroxed at that moment. It's like, no, they are the same thing, right? It's like I'm like pulling. It's like they're one person. I'm pulling two different arms. Like if I pull one arm, the other arm's gonna like move alongside of it too, right? So they're the same exact thing. Okay. So okay. Two more slides. Okay. Okay. So this is just an example of when we think about functions of how they kind of robust it could be. Notice how in this calc function, right, we have two initial values, num1, num2, could be any number, doesn't really quite matter in this case. We have a sum function, and this sum function does what? It returns this dot num1 plus this dot num2, right? Function basically adds in the two numbers together, and then a difference function that does the exact same thing, except now we calculate the difference. Notice how when I write calc, I do calc.sum. It logs out 50, right? And when I console log out calc.difference, or when I change num2 here to 15, this becomes 15, right? So when I console log out calc.difference, it becomes 5, right? And so what does this tell you? What this tells you is that like these functions don't run until you call them. And whenever you call them, it's almost like at that point they'll go and fetch these numbers like at that point in time. So this makes the functions like, I guess real time, if you want to think of it that way, right? It's not like, oh, if I create an object with a function, like when I at the point of creation, these functions are what they are. It's like, no, like these functions are dynamic. Like if at any point I want to change the array, I want to change the object or change any of these values, well, they're going to reflect those changes. So whenever we use object methods, it's also really critical to understand not just, like we can see when it was created and kind of make some assumptions there, but we also need to make sure like, hey, was any intermediary value changed in the meantime? And then the last kind of thing we'll talk about here is just, is just that This is a super complex idea. We're talking about it only in the context of object methods. So there will be some kind of gray areas. There will be a lot of unanswered questions. And quite honestly, it's probably not in the best interest of this class's time to go through like too much on this. We basically bring it up here because when you use object methods, it's a very common paradigm to say, hey, let's use this, right? It's the safest, most direct way to reference something itself or whatever. But you might see this used in other contexts too, and that's very normal. Like there are a lot of other applications of this. So once again, we're just kind of going through this at a very high level for what you need for the workshop and probably for the interviews. But there's more to this iceberg. And that's pretty much it in terms of content. Will, was your question answered? I'm blanking on what the question was.
No.
Okay, let's try it.
With in that example, I guess with the Grace Hopper or any of those objects.
Yeah.
When you use this instead of, I guess what would happen if it was nested in, if you
Oh, I see.
created like a function around Grace Hopper.
Yep.
Or anything around it.
So what if, so why don't we do this? Okay. New obj is equal, let's call it, my indentations, right? Oh no, these two are off.
Yeah, so in that case.
Oops, did not mean to. So, okay, Grace Hopper dot new obj dot get this, and then let's just console log out return first. I don't need this line anymore. So like in this, like everyone can see this, right? Like when we talk about like in this, in the form of this, the question becomes kind of like, who does this function belong to, right? And the short of it is this function belongs to like kind of like the last party that calls it, almost. And so when I look at this function, it's like, okay, this is a value, right? Which object does it belong to? It belongs to this object called new obj, right? Who new obj belongs to or inherits from is a much different question, because and rather what this is trying to do is saying, hey, as long as you have access to new obj, you will have access to this function. Right, so it does get a little bit confusing too, because there's a very valid argument for, well, why doesn't this kind of go to the very root of whatever it is, right? And that once again, I think that's a much more complex topic that probably touches on like the aspects of JavaScript inheritance and why we do it that way. But for now, just kind of when we talk about this in the context of object methods, it's simply quite like, what object does this function belong to? Like, what object is this function of value of? And there's a bunch of ways we can kind of twist around and wrap different things around it. But like, it's probably not as useful to memorize all of those kind of scenarios, and just more to think, okay, when I'm using this, the question is, who does this function belong to, right? And just go with that. So like I would like if I have access just to Grace Hopper, right? In this case, I wouldn't be able to call Grace Hopper dot get this, right? That would fail, because if a computer goes through and looks at the keys of Grace Hopper, there's no get this, right? There's no get this key, and so that will fail. And that's why get this does not belong to Grace Hopper, right? It belongs to new obj, because once again, if I have something referring to new obj, then I can just say new obj dot get this, and now I'm looking at a valid, if you will, like a valid function call. Obviously, to get access to new obj, I need to get access to Grace Hopper, so it's kind of like a chaining effect, right? But what this is concerned about is just what do you need access to so you can call me directly. How you get access to that is a completely different issue, right? In this case, we didn't go through Grace Hopper to get new OBJ, but as far as this is concerned, this is just this new OBJ object. Cool.
Yeah, thanks. That helps.
Any questions? Yeah.
So just to clarify, can you just set let returned objects equal this dot get this? Would that just return a new object?
Let return object. Okay, so if I do this dot get this, what's going to happen? Oh, this is a reserved word. Okay. Let's guess what's going to happen here. Oh shoot, never mind. I was going to say reference error, but it's not a reference error. No, wait, no. It would be a function call error. Yeah, this is not a function.
So why does it not pull up new object if like get this is within new object's object?
Right. So so let's talk about why this get this is not correct or not not usable, right? And the short answer is because we never define what this is. Does that make sense?
I feel like we haven't defined this at all. I feel like you just said it was just like a keyword in JavaScript that we should just know is existing.
How should I do? Oh, okay. I think Tyler, let me know if I'm wrong here. I think your question is more like, can we do this dot get this, or sorry? Oh, okay, whatever.
I just thought like when we were doing this, you said it relates back to the object that it's contained in. So my thought process would be because it's an object within an object, it would return new object because this dot get this is within new object.
Right. So the problem with with just making that assumption here is I could have something like this, right? And now by your definition, I now have two different thises floating around, right? So when I do this, it's not quite clear which this I'm referring to. And in fact, in general, so now we are going down the rabbit hole like what this is and something I didn't want to do, right? Which is that this always exists, right? But it may not exist for what you think it does. Earlier when I was calling this dot get this, at first I was gonna be like, well, this is gonna throw a reference error because it's gonna tell me that this doesn't exist because we never defined it. But then I realized it won't, because in this case, everything on this page is part of the global object.
Of this.
And so when we use this becomes synonymous with global object. And so when I call this dot get this, what it does is it remember the hoisting thing where it scans through the page and looks for all the variables? Get this theoretically does not exist yet, right? Grace Hopper exists, return object exists, nothing else does. And so that's why the get this wouldn't function. If I just console log out, if I get rid of all of this, and I just console log out this should be the window object. Oh, okay, well, REPL doesn't let you do it, but hopefully just even from this, you can kind of see this becomes almost like this website's domain, right? This website page, this window is this.
So scope matters a lot here then, right?
Scope matters significantly.
Yeah,
yes.
so it's just, that makes sense, perfect sense, and it's just nested scope levels, I guess.
Yeah, yeah. I don't want to say definitively yes, because I think there's additional complexities that quite honestly I'm not even super clear on between scope and this. But for now, at a high level, if that clarifies the picture, that will do for the time being. Yeah. The other reason, so when I say this is always defined, it's almost like saying okay, bad analogy time. It's like saying there's going to be a light switch in every single room you go into, right? But they're not all going to turn on the same light. Right? So if you walk into a room and you start flipping that room's light switch and you expect the light in the previous room that you just flipped to turn on, it's probably not going to work, right? Because every light switch is tied to that particular room, that particular room's scope or that particular room's context, something to do with that particular room. right? So if I was in one room, I flip on the light switch, like, oh, great, this light turns on. Therefore, light switches must turn on this light bulb. I go to another room, I flip on the light switch. It won't work that way because that room's light switch is tied to a different environment altogether, right? So whereas this always exists, it doesn't always refer to the same thing. And in fact, in this floor alone, right, we have multiple rooms with multiple light switches. If someone sees it, they would say like, oh, there's like 5 instances of this on this room. But unless you're very clear about which one you're looking at, it's really hard to elegantly like precisely use it unless you know exactly which environment you're playing around. Amir.
So this just again, but so it's just that particular this is location.
Yeah, like this
like
is
that this the definition of that this where it exists right now.
Yes, it's based on the definition of this is based on where it is defined. Yes. Although, actually, you know what? So now we're getting the realm where even I'm getting confused, to be honest, because of. But what if we do something like this? Okay. All right. So we create a function called getThis, and it returns this. Okay, cool. And then what I'll do is I'll make this the value, or I'll make the getThis function the value of new object, and also of. Wait, what am I doing? That's not right. Okay, right. So this will be test, and this will be getThis, and the newer object will also do it. So now this will tell us, is this predicated on where it's called or where it's defined? Okay. So the code should run, right? So then if I do, let x equal gracehopper dot new object dot test. Okay, console dot log out x, and then this will be new test y, and this will be okay. All right. Okay. So the reason why I didn't want to say it's based clearly on where it's defined all the time is because notice how in this example I defined this only in one place, right? On line 2, that's the only place I write return this. But if I look on the code, I use it in 2 different places. And when I call each of these different places, I get a different this back. So I guess in the previous example, it was based on where it's defined, but I guess the more important thing is when the this is invoked, where was it at? And it will capture the environment in which it was being invoked. If this doesn't make sense, it's totally fine. Feel free to just not read too much into this for now. But I just want to make sure we answer that question thoroughly. This is defined not based on where it was created, but based on where it is used. Right.
How
Yeah.
can it be defined on what's created if it's always built in?
I'm sorry?
I have no idea how to phrase this question. How, what you just said with this not being defined by where it's created.
Yeah.
How can we create it though if it's always?
When I say created, I mean where we define it, right? So get this. This is gonna really have your mind blown.
Scope defining function is calling a function inside the object.
We can actually even call getThis outside of any object. Whoa. Okay, well, you get the idea, right?
So you just define a function as a global variable and just calling it inside the object, right?
Mhm.
When I'm calling it, you're just passing it through into the object.
Yeah, kind of.
That's sort of
Well, you don't need access to gracehopper to call getThis.
But we have this as defined up there.
We
Oh,
don't.
yeah.
So we define this gets it right. So like here the point is like we invoke get this. So get this just returns the version of this, right? We invoked it or we put it in 3 different places, right? On the global scope, in this new object, and in this newer object, right? When we invoked it at all 3 locations, we got 3 different versions of this. And I guess the point I'm trying to make here is that like even though we say like we wrote the words return this on line 2, what really matters is when we actually execute this function, where the context for that like who invoked it. Like that's a lot more important than where we defined it. Because if I looked at this as like, well, technically speaking, I defined this function is part of the global scope, therefore this should always be the global scope. But that's not the case, right? It depends upon like where it was used. Because in this case, when we ran get this as a value of new object, this new object becomes the context for using that this.
So if you're declaring a variable, just passing it in somewhere else.
Declaring variable versus passing
No,
it.
I'm saying you're declaring a variable, a function as a variable, and just passing like any
Yep.
parameter just inside an object.
Yeah.
And then when you call a function inside the object, it's just gonna follow the context of where it's currently located.
Right.
Okay.
Emily?
And it doesn't matter if you use bracket notation or the dot notation.
Nope. So if I want to do because at a certain point, right, everything is just an object. So like that gives me the same exact answer.
But you have to use brackets when you have like a 2-part, like a.
Yeah.
it's not
For
one
anything you
word.
can't represent as a continuous string, then yes. And do you have a question about?
So in this case, if we weren't in RepIT, so you would equal get this.
You would get the global window scope probably. And if you want to see that, once again, right, like there's ways to do all of this. So this is a Chrome console. So this comes built in all Chrome, and this lets you run JavaScript in the Chrome browser because once again, all internet browsers just run JavaScript. They're all JavaScript machines. So this is the same code we had before, except now I'm running it in Chrome, right? So I have my test, I have my new test object, and now I have access to the window scope. In REPL, it blocks you from looking at the window, probably for security reasons. But essentially, this you can think of window as like the global scope. So because I defined this on the global scope, this when I run it just a la carte, it comes back as a global scope. Yeah, I mean,
If you put parentheses next to get this on both of the tests and new tests, would that change anything? In terms of like how it compares to some logs
parentheses where?
next to get this. Can we do
Which line?
next to test, like test and then get this and then parentheses?
Oh, I see what you're saying. Probably easier to go back to REPL then. So your thing is if we invoke these functions, right? This is a good question. I'm trying to think what this would be. I guess it doesn't really matter if we just run it and we'll find out. But if I run this, this would still probably be the window scope, would be my guess. Oh, sorry. Okay, yeah, this will all be the window scope. Just,
So it's all the same as this.
right, because when I, yeah.
Is the difference instead of
What do you mean that Grace Hopper has already been declared? What? Oh. Oh, shoot. This is silly. There we go. Yeah, in this, so in this case, when I run get this, when I actually invoke get this is invoked at this point in time. And so in all 3 invocations, I'm pointing to the same get this. So therefore, when I print out, I'm getting three references to the same exact thing, which is a global scope that this was attached in the first place. Okay.
would it be correct to say then without the parents after get this inside new object or new obj, you would just be saying you're passing in the variable, the function to that place, and with the parent, you're saying invoking the function as it exists previously, where defined.
Yeah.
Okay.
I'm gonna stop taking questions on this
Yeah.
for now because I feel like this is like not like super critical for today's workshop. Let me okay, so I guess like we've also reached like the halfway point of the curriculum. So today is like the first day on the other side, if you will. We can start thinking about like like what's been working, what doesn't work. So I just opened up the workshop for everyone. Okay, so I'll do the first problem kind of like not for you, but like we'll work through it together as a class. Because I think one of the things that's like hard with the workshops is that like it's different from the slides. Like on the slides, we're just isolating one concept and writing it out for you really clearly, and it makes sense. But then when you do the workshop problem, because we're combining with other things, it becomes a lot less clear. So I'll do the first workshop problem. Like we'll do it now together as a class, and see if like that helps set the table better for the rest of the workshop problems. Because I also don't want we talked about a lot today, and like I don't want everyone to get super stuck on the first one, like not know how to get started, because there's a disconnect between the workshop problems and like the slides. Okay, so you can the workshop's open now. You can go on your computer and like look at it too alongside me if you want. I'll just kind of do it live for you right now. Okay, so the say my name problem says define an object me that has a name property and a get greeting method, and get greeting should return a method. Actually, this is maybe this is not the best problem, but let's go for it for now. Like this is basically like something that we just kind of talked about already in the slides with the Grace Hopper example. But if I was to do this problem, right, usually I kind of take it one step at a time. So before we even write like any real code, one of the things that like when we're trying to solve these problems, it's good to just kind of keep a running tab of all the things we have to do, and as we do them, we kind of cross them off the list, right? So the first thing that this helps me do is create an object called me, right? The next thing we're going to do is me has a name property. 3 is me has a get greeting. I'll say property method. Like I'll use those two chains. I'll say they're the same thing for now. And then 4 is get greeting returns a string that includes the name, right? And so when I do this problem, the first thing I'll say is, okay, so I need to create an object called me. I can just do something like this. Let me equals this. I can kind of cross this first step off my list, right? The next problem is me has a name property. So I can just say name. Great. I'll give it a name of David, comma. And now this is me going through the second checklist. The next thing is me has a get greeting property / method. So that just means get greeting is going to be a key. And then for the method, it's going to be a function. I don't know what it is yet. I don't really care quite yet, because all I need to do is make a function that's a value on the get greeting key. So now I've done the third part. And then the last part is get greetings, singular. Get greeting returns a string that includes name. So I'm going to do return. I can just do a string that has a name. So I can just do hi plus, and then this is kind of where like the trick is, like how do I get access to that name property? I could easily call me.name, or I could call this .name, right? They're both synonymous in this case because this is me. So I'll just also say me.name also works. And I comment out this. And so when I run this now, this should, oh, I have a failure.
Hi, my name.
Oh, hi, my name is,
Yes.
okay. I guess I can't just return my random greeting. Cool. Now I run this. Huh, did I misspell hi, my name is?
Period.
Oh, nice.
Nice.
last time.
Yeah, that got us before.
Cool. All right. So when you do these problems, it also helps just kind of be like super organized, like in terms of like understand, like really thoroughly understanding the problems that and what the problem is asking. If you're ever doing like I know like I did this and this problem is super simple, so it almost seems kind of silly to do it this way. But if I if you're ever working on a problem and someone asks you like, oh, can you define like in the real engineering world, like this is like a product spec, right? These are the quote unquote like this is what we call the requirements of the thing that you're building, right? Like what does it need to be able to do? If you can't define these very clearly, then it means you don't understand the problem, and it means you need to like read through and think through the problem some more. Like when you read a problem, like seriously, writing code, even if it isn't now, writing code will be the easiest part of like solving an engineering problem. The harder problem is thinking through, understanding, and knowing what to do. And once you have these steps laid out, like typing the code, it becomes like super simple, right? Like at no point did I need to like I did all my thinking when I wrote this, not when I was writing down the code, right? Because like create an object called me, like I don't really need to think to do that, right? But knowing, understand like, why I'm creating that object, like the thinking happens when you're laying out the project. So, like if you ever see like a waterfall of like code writing, usually I think code writing is around like somewhere between 20 to 25% of an actual project. Like a lot of times when I walk around at workshops, it's kind of clear that like when a team's working on a project that like they didn't really quite understand the problem. They thought they just wrote enough code, they would like kind of back into a solution. And sometimes it works, but often not. It will take you much longer because trying to write code without knowing what to write is kind of trying to drive somewhere without like knowing the directions. Right? It's like, yeah, if you make enough wrong turns, eventually you'll hit the right thing, but it's just a lot more painful. Okay, any questions about object methods, or anything from today's workshop problem? Or from like any questions looking ahead to today's workshop? I can also just read through the problems together, so we can like kind of just make sure like we all understand them. So say my name. We did. Say your name. Create a new object. Me too. Okay, so it looks like we're just copying the object from the previous problem. We're editing the myGreeting method so that rather than just being able to say, hi, my name is David over and over again, we're customizing that function to also be able to take in an argument, right? And that argument will be someone else's name. So then we can say like, hi, hi Tom, my name is David, right? So it makes our function a little bit more flexible, and basically it enables our function to be able to be used with outside data as well. So it's not just always like forward-looking or inward-looking. The next one is a function called call them all. Write a function, call them all, that given an object and a value, calls every method in the object, passing in the value as the argument with each call. Okay. And then call them off return array, the order does not matter. Okay, cool. Right, so what this is saying is, let's say I have an object, right? And on this object, I have 10 keys, and every single value for one of those keys is a different method. Cool? Right, so now I have an object with essentially 10 functions, 10 methods in it, right? What I'm trying to do here is I'm trying to call every single one of those functions, and I'm gonna, based on the way the problem is written, what I'm gonna assume is every single one of those 10 functions is expecting an argument, right? They're expecting me to give it something when I call it. And so what my function is going to do is it's going to take in that potential argument. It's going to take in that object with 10 different functions. It's going to loop through that object with 10 different functions, and it's going to call every single one of those functions with the argument that was initially given to me. Cool. It's like the analogy here would be like, let's say someone gives you a name and they give you a stack of hi, my name is name tags, right? Your goal is to go through that second name tags and write that person's name on every single one of those name tags. Okay, and then when we call those functions, each time we call it, it looks like it looks like based on the way the problem is written, we're also expecting that function to give us back an answer, right? Otherwise, why would we call it a function? And so we also want to store that answer in an array. And because there are 10 different functions, we should be getting back 10 different answers. And each of those answers should occupy a slot in the array. It should be an item in the array. And the order of the array does not matter because when we loop through an object, there is no order. And so we can't really particularly say like this object will always be called first or second or third, etc. Make sense? Yes? Okay. Tic-tac-toe problem. Define object tic-tac-toe. Create a board property, move and clear. Board is a grid of arrays. Okay, so the board property, yep, it's just looks like a grid of arrays. That just sounds like the nested arrays we did like a couple of days ago, right? And each cell is null, right? So each cell starts with like a null value. Notice how here we're using null, right? Not undefined. We're using null to say that we've looked over we've created this square and we're intentionally saying it has no value presently, right? Like that's just like this is like a textbook example about why we use null. The board property, the move method means that given a character the move method takes in basically a row number and a column number, like a coordinate. And what it does is it basically, the move character takes in like, if we're playing tic-tac-toe, we'll say either an X or an O. It'll take in a row number, or an X-axis number, and a Y-axis or column number, right? So if I do like X, 1, 2, it will go to the 1, 2 like coordinate and put an X there, right? And that's what a move is, right? It's like we basically go to a square and we put in like our marker. One thing we probably also want to be clear here or be careful here, and this is kind of maybe a deeper level of thinking about the problem is before we move something, we also want to make sure there's nothing there previously, right? Because we can't drop our X if someone else's O is already there. So that's just like an example of like kind of thinking through the problem. And then the clear method, pretty straightforward, we reset everything to null. I guess what this function doesn't do is it doesn't tell you when someone wins, but I guess you can figure that out yourself. Yeah, Tyler?
I just have a quick question. When you say method, does that mean it's a key or is that a function?
When I say method, it means the name of the function. And so method and functions are the same thing. When I say method, it just means the name of that function will be the key, and that function itself will be the value of that key.
Okay, got it.
Yeah. Sure. So method and functions are the same thing. So if a method is a function, basically the name of the function will be the key name, and then the function itself will be the value associated with that key. Okay, last problem, taco cat. Okay, given object. Given an object that presents inventory company, add a milk. Okay, so here it's kind of like yesterday's problem with like the calculating expenses for like last Friday night, right? Someone's going to give you an expense sheet of all, or an inventory sheet of everything that you own, and your goal is to, based on that sheet, and I guess what we can say here is we can make some assumptions that hey, no matter what sheet someone gives you, it will always look like this, right? It will be like, like a key. You'll have an object, and the objects within that object, the key will be the item names. You have a cost and quantity. We can kind of assume that it will always follow that format, despite how many items you may have, right? So the number of items may change, but it will always be that format. And so your first. So if I give you that inventory, your first thing is tell you, hey, how many dollars worth of inventory do you have, right? And that's basically going through this entire list, going through every single item and figure out what the cost and the quantity is, and you multiply those, right? And you add it to a right ticker of how much inventory you currently have. We also added a sale method that takes an order object. Okay. So this sale method expects to take in an order that says, basically, I want to buy cat grass. I want to buy 1 unit at however many or however many units you want. And then that's what we need to do is we need to look it up and look up in our object. One, do we have the inventory for it? and 2, how much did it cost, and then once someone buys it, then we remove it from inventory, right? Because now we've sold it. So it's basically like almost like an accounting kind of function, accounting software that you like. I give you a sheet of what we already have, and now we can do transactions on top of it. Make sense? Like not make sense of like you know how to do it, but does the problem make sense in terms of like what it's trying to get you to, like what the purpose of the project is? Cool. Yeah, Claire.
Don't we need to have like a value or a variable for how much the sale is? To code that in? Or do we just make an empty variable?
Oh, okay. It looks like what order does is when it says it takes an order object, it looks like what it's like. And I'm saying this based purely on the example code that they gave us, right? So this sample code tells you how they're gonna run the test, right? If you look at the highlighted portion there, I guess the point is here that like the order just tells you what they're ordering, and I guess the assumption is that they only buy 1 unit at a time. Right. So in this case, if I'm buying salmon, like I don't say like I want like 5 units of salmon. I'll just say salmon, and that means I want to buy 1 unit of salmon. So a little bit inefficient there, but yeah. Okay, cool. I think I'm done talking.